This conference will now be recorded.
Right, we are at structural and distance properties of convolutional codes. In the last class, I completed a few formulas. So free distance and some of the formulas, some of the definitions, forward path, loop, non-touching loop, and with the assumption of ith forward path, Fi is the gain of the ith forward path, Ci is the gain of the ith loop, and set I, set Ij, set Ijk. So all these are completed, and finally formula is the generating function, that is T of x is equal to, what is the formula? Sigma I Fi delta I by delta, right? So what is our discussion actually? What is our discussion? You have to find the weight enumerating function, right? So weight enumerating function. Now in order to obtain the weight enumerating function, you have to find the weight distributions, and in order to get the weight distributions, you have to modify the state diagram. Do you remember or not? So in order to draw the modified state diagram, from the state diagram you have to follow some conditions here. Already I told that nearly 3 to 4 conditions, and with the help of those 4 conditions you have to draw the modified state diagram, and from the modified state diagram you have to identify what is the forward path and how many number of forward paths are available, and how many loops are available, how many non-touching loops are available. By finding all those things, you have to substitute into the Mason's gain formula, then you will get transfer function or generating function, right? Yes, am I audible?
Yes, sir.
Okay.
Yes, sir.
Okay, right. Now continuation of the last class. Next continuation is, so up to this, this is the formula for modified state diagram. Now I want to go for the modified state diagram can be augmented. That is, I want to go for the augmented state diagram. So augmented means, that means you have to increase by adding something. So that modified state diagram can be increased by adding something. So from the previous discussion, I told that in place of 0 0 or in place of 1 1, in place of 1 0, that means in place of outputs you have to write x, and weight can be represented like x power I. Do you remember this? X power I. What is the meaning of this? What is the meaning of x power I? Yes. What is the meaning of I here? I is the weight of the output bits on that branch. So I is nothing but weight here. So that means what I want to say is, for example, when you go for the state diagram, 0 0 is the one state, or 0 1 is the one state, and 1 0 is the another state. If the state present state is 0 1, next state is 1 0, for example output is 1 1. This is the actual state diagram. Now when you go for the modified state diagram, instead of writing 1 1, just you have to write x power 2, because your weight is equal to 2, right? For example, output is 1 0, at the time you have to write x power 1. Is it clear? So these are the points you have to remember if you want to draw the modified state diagram. Okay, so after the modified state diagram, now I want to go for the augmented. So augmented state diagram, that means you have to increase that modified state diagram by adding something. Here I want to write only x. Now I want to add something to this x. Those are y and z. So here what is y, what is z? So that is important. That means what I want to say is, now the augmented state diagram, this augmented state diagram can be obtained by labeling each branch corresponding to non-zero message bit with y. So non-zero message bit with y, and labeling every branch length is with z. Here This indicates only weight here. Weight here, this I here, x power 1, x power 2 like that. Now I want to include the message bit also, either 0 message bit or non-zero message bit. So the message bits can be represented with y here. Similarly, I want to indicate the length also. The length can be labeled with z. So once again, so see the example here. For example, 0 1, again 1 0. So we know that, so for example, input is 1, output is 1 0. Input is 1, output is 1 0. So output 1 0, that means x power. So weight is 1, so 1 like this. Now input is 1 here. Now you can write y, and the length of the input is 1 here. Then you can write z. Now you have to label this branch or this line with x, y, z like that. So this is the augmented state diagram, and previous one is and this one is the modified state diagram. This is the modified augmented state diagram. So here the meaning of augment nothing but you have to increase that by adding something. And coming to exams also depends upon the question. Whenever the question is modified state diagram, and draw the modified state diagram and find the generating function. At that time go for this. No need to add y and z. Suppose the question is augmented state diagram in terms of y and z. That time you have to go for this. No problem. I will give an example. Then you will get the clarity. Now I want to write the generating function for this augmented state diagram or transfer function for this augmented state diagram. Now look at that formula. Another formula is, write down the formula. Augmented transfer function is given by, augmented transfer function is given by here x, y and z. Sigma. So x power I, actually in previous case x power I, that means only I, but yz, two other variables also there. So I want to take I, j, l. So a, I comma, j comma l, x power I, y power j, z power l. So this is the augmented transfer function. Don't confuse, it is easy to remember. Sigma ijl, aijl, x power I, y power j, z power l. where aijl is the number of non-zero sequences. I'm repeating once again. aijl is the number of non-zero sequences of weight I, comma, whose corresponding information sequence has weight j and which has length l branches. Now clear about this? In order to indicate the weight, you have to use I, that is x. To indicate the input sequence, that is y, that is j, power j, and l is the length. I'm repeating once again. aijl is the number of non-zero sequences of weight I whose corresponding information sequence has weight j and which has length l branches. So in order to indicate the length, you have to go for z. In order to indicate the information sequence, information bit, you have to go for y. In order to indicate the relative weight, non-zero sequence weight, you have to go for x. So I, j, l, x, y, z. Okay, that's it. That's it about the augmented transfer function. Now, what is our topic actually? Structural properties or code properties. Structural properties or distance properties, or you can say that properties of convolutional codes like that. Whenever the question is only distance properties, just you have to go for free distance formula. And coming to structural properties, you have to go for like this, the modified state diagram, augmented state diagram, all these things. And I told that you have to go for all these things because of finding the weight enumerating function. That means you can say that the weight enumerating function is the property of the encoder. Weight enumerating function is a property of the encoder, or you can say the structural property of the encoder. And here what I want to say is not only weight enumerating function, there is some forms here. So we are having a input output weight enumerating function and input redundancy weight enumerating function, and another one is conditional weight enumerating function. So I am repeating once again. Suppose only 5 marks question, write only properties. At the time you have to go for these are the properties of the coder, weight enumerating function and input output weight enumerating function, input redundancy weight enumerating function, cumulative weight enumerating function. So all these are the properties of this convolutional encoder, structural properties of this convolutional encoder. In order to get all these things, you have to go for the weight distribution. That means you have to modify the state diagram, and you have to calculate the transfer function or generating function with the help of Mason's gain formula. Okay. Right. And here you have to know formulas for each and everything, and what is the relation between all these things you have to know. So first one is about the just 1 or 2 points only. First one is about the IOWEF, input output weight enumerating function. So it is the property of the encoder, and this function contains only information about the input and output weights, and the name itself indicates that input output weight enumerating function. This contains only information about the input and output weights, but not on the length of each code word. Now only I told that. So x indicates like output weight, and y is for input weight, and z is for length of each code word. So length of each code word. But here when you go for the function IOWEF, it contains only information about the input and output weights, but not on the length. What is the meaning of that? No need to take the z, only x and y is required. So this IOWEF can be obtained with the help of the formula T of x comma y. No need to go for T of x comma y comma z. So meaning of that is T of x comma y comma z, where z is equal to 1. So I am repeating once again. IOWEF that contains only information about input and output weights, but not on the length of each code word, and it can be obtained as T of x comma y equal to T of x comma y comma z, z is equal to. Already we know the formula, right? Already we know the formula for T of x, and we know the formula for T of x comma y, and we know the formula for T of x comma y comma z. And you have to substitute like T of y formula, T of x formula, T of x comma y comma z formula, like that. Suppose if you want to get the IOWEF, you have to assume that z is equal to 1. That's it. That is the meaning of this. And similarly, next one. So this is IOWEF, and next function is weight enumerating function. Already we know about this weight enumerating function. It is also code property, and this weight enumerating function is having some relation with the IOWEF. So that relation is T of x. Listen carefully, very simple. So weight enumerating function, it concentrates only on the output bits and weight of the output bits. And when you go for the IOWEF, it contains only information about the input and output, not only on the output, input and output, but not on the length of each code word. That's why z is equal to 1. Now I want to write the relation between these two. Weight enumerator function only output here, and input output weight enumerator function in the word input also. So you can write the relation as T of x is equal to T of x comma y, where y is equal to 1. Suppose if you want to write with respect to length also, you can write x comma y comma z, where y is equal to 1, z is equal to 1. Right? T of x comma y, T of x comma y comma z, z is equal to 1. And weight enumerating function, T of x is equal to T of x comma y, y is equal to and that equal you can also write as t of x comma y comma z, y is equal to 1, z is equal to 1. That means you must be clear about what is x, what is y, what is z, and what is x power I, what is y power j, what is z power l. So you have to you must be clear about all those things. Then only you will get the idea. Otherwise, you will have definitely confusion, right? Clear about this? Any doubts? Yes, respond please. Any doubts?
Yes, sir.
Doubts, sir?
No, sir.
Okay, right. Is it clear or not?
Yes, sir.
Just simple. Actually, I am talking about the weight enumerating functions, and WEF weight enumerating function. IOWEF is input output weight enumerating function. Next, I want to write the formula for conditional weight enumerating function. That is CWEF. Conditional weight. Rishita, please give your statement. Rishita. Yes. So conditional weight enumerating function. So here, this function enumerates weights of all code words associated with particular information weights. I'm repeating once again. This function enumerates weights of all code words associated with particular information weights. So that is the meaning of conditional weight enumerating function. For example, for information weight of j, the CWEF is obtained as Tj of x is equal to sigma I a comma j x power I. Right? I'm repeating once again. Conditional weight enumerating function enumerates weights of all code words associated with particular information weights. So enumerates nothing but it describes actually. It can describe weights of all code words associated with particular information weights. For information weight of j, the conditional weight enumerating function is obtained as Tj of x is equal to aij x power I. Now here, what is the meaning of aij? So ai comma j. So ai comma j represents number of code sequences with weight I and information weight j. In the previous example also I told that x power I, y power j. So x power I, that I indicates weight of output sequence and j indicates weight of information digits. Weight of information bit, that is nothing but weight of input. Similarly here also ai comma j represents number of code sequences with weight I. Code sequence nothing but here output sequence. Number of code sequence with weight I and information weight is j. Is it clear? So this is the conditional weight enumerating function. Now I want to write input output weight enumerating function in terms of conditional weight enumerating function. Now, so I want to write input output weight enumerating function in terms of conditional weight enumerating function. What is T of x comma y equal to sigma j y power j Tj of x. Okay, so input output weight enumerating function nothing but T of x comma y. Already I told that, right? So output nothing but x here and input nothing but y here. Don't think that output is x, input is y. Don't think like that. Here my notation is in order to write the output weight, I want to write x power something, and here to write the input weight, I want to write the y power something. So here input output weight enumerating function, it includes x and y. So t of x comma y that is equal to in terms of conditional weight enumerating function I want to write, and I told that for CWEF information weight of j, that is tj of x. So sigma j y power j tj of x. So this is the relation between CWEF and IOWEF. And finally, so another one is input redundancy weight enumerating function. So input redundancy weight enumerating function. What is the meaning of this? Can anyone? Input redundancy weight enumerating function. Redundancy, redundant bits. What is the meaning of redundant bits? Redundant
Repeated.
bits. That is okay.
Bits.
That is okay, but when you go for the code word, I told that when you go for the systematic code word, mainly this is comes into picture when you go for the systematic code word. So when you go for the systematic code word is having the input bits and as well as redundant bits or check bits or parity bits. Is it true or not? That means suppose if I want to represent the weight of code word, you can go for I directly. So weight of input, I told that y power j like that, and weight of output x power I like that. Now I want to go for weight of redundant bits, weight of only parity bits. Once again I'm repeating, when you go for the code word is having input bits and as well as the parity bits. So combinedly you can say that is the code word when you go for the systematic code word. So that when you go for the systematic code or systematic convolutional encoder, I want to go for the weight of weight of parity bits, but you can't get directly weight of parity bits. That output bits containing, that is output sequence having input bits and as well as the parity bits. That's why here I want to separate input and as well as the parity. So input and redundancy. That's why your heading is input redundancy weight enumerating function. Now that's why it is only for the systematic encoder. Remember that, because when you go for the non-systematic encoder, it's not possible to separate the input bits and redundant bits. Is it true or not? When you go for the non-systematic code word, it's not possible to separate the input bits and parity bits. So when you go for the systematic encoder, then only it is possible to identify the parity bits from the output sequence. That's why I want to go for systematic encoder. So it is defined. It is defined for systematic encoder as follows. It is defined for systematic encoder as follows: w comma y comma z is equal to. See here I didn't write x. Reason is I don't want to go for the output here. So input and as well as the redundance. So redundance is w, I want to assume like that, and input is y. So w comma y comma z is equal to sigma w comma j comma l, a w comma j comma l, w power w, y power j, and z power l. So where a w comma j comma l is the anyone, any guesses? Number of code sequences. Number of code sequences is the number of code sequences of what is L here? Length. So length L with what is J? What is J? Anyone? Please respond. What is J?
Information.
Information weight.
Information weight.
Right, very good. So with information weight is J. Repeating once again, a w comma j comma l is the number of code sequences of length L with information weight J, and what is W? Now only I told the W is the parity weight, and okay, redundant or parity, whatever it, and the parity weight is W. That's it. where a comma w comma j comma l is the number of code sequences of length l with information weight j and parity weight is w. This is the formula for input redundancy weight enumerating function. So that's it about the weight enumerating function definitions. A brief once again, IOWEF, WEF, CWEF, IRWEF. Suppose for example question is write about the properties, means you have to write all these things. Okay, and relations also I have given. Next, directly I want entering into the examples, right? Now do this example, then you will get the full clarity, 100% clarity, I am sure. Take an example. Consider rate 1/2 encoder. Rate 1/2 encoder with m is equal to 2. So don't think that so encoder with m equal to 2, what is the meaning of this? It is a 2, 1, 2 encoder, right? So don't think that only 2, 1, 2 encoder. It may be anything like 3, 2, 2, 2, 1, 3. It may be anything. But already I have given the convolutional encoder diagram for 2, 1, 2 encoder. That's why I want to go for that example, because here again I don't want to draw that encoder diagram. Okay, consider 1/2 encoder with m is equal to 2. And here I want to write the output sequence as VL1 equal to UL plus UL minus 2 and VL2 equal to UL plus UL minus 1 plus UL minus 2. Do you remember this? Yes, do you remember this?
Yes, sir.
Okay, you can draw if you want to draw encoder diagram, you can draw, no problem. Easy. It will take only 1 minute, right? So it will take only 1 minute. So this is UL, this is UL minus 1, UL minus 2. And what is VL1? VL1 is the UL plus UL minus 2. Simple. This is VL1 and that's it. This is VL2. This is the 2, 1, 2 encoder. Now I want to get the transfer function. That means first I want to draw the modified state diagram. So in order to draw the modified state diagram, first you have to draw the state diagram. Look at the order. So in order to draw the modified state diagram, first you have to draw the state diagram. That means first you have to get the encode sequence with the help of graphical approach, that is state diagram approach. I think we completed already, right, for this problem. Can anyone please tell me the state diagram? Once open the problem, and what is the present state, what is the output state, and what is the input, what is the output. I think you know about all those things. Completed or not? Already we completed, I think. Look at once. Yes, completed.
Yes, sir.
Yes. Okay, good. Now tell me. Here how many number of states? Actually 4 states, right?
Yes,
Number of
sir.
states are 4 states. Suppose 0, 0, 0, 1, 1, 0, 1, 1. Now tell me. Present state is 0, 0. Input is 0. What is the output state?
0, 0.
Right, 0, 0. Okay, that is 0 by 0, 0. You can write like this also, no problem. Now present state is 0, 0. Input is 1. What about the output state?
0, 1, sir.
Input is 1.
0, 1, sir.
Sure?
Yes, sir.
1, 1.
I think 1, 0.
1, 1, 1.
Output is 1, 1, right? Output is 1, 1 and next state is 1, 0, I think, right?
0 1 sir.
0, 1, sir. 0, 1, sir.
0 1 sir.
Sure?
Yes, sir.
Check the problem once. Is it UL plus UL minus 2 same problem or any other different problem? Look at the output equations. Look at the output equations. Output equations are here. UL plus UL minus 2 and UL plus UL minus 1 plus UL minus 2. Look at the output equations.
Same problem, sir.
Problem, sir.
Same.
Yes, sir.
Then present state is 0 0 and next state is 0 1.
Yes, sir.
Then why here wrong answer? Okay, once again I want to do that. Wait. Okay, right. Let's directly go for here. I want to write the answer. First input, present state. Next outputs, next state, right? So 0 0 0. Or you can write like this. Sorry, you can write input here. Okay, 0 0 0 0 0 1 and 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. Let's comment outputs here. What are the outputs? UL plus UL minus
-2.
UL plus UL minus 1 plus UL minus 2. And here this is present state is UL minus 1 UL minus 2, right? Is it okay? No, I think UL minus 2 UL minus 1.
UL minus 2, UL minus 1,
Yes, sir.
sir.
And this is UL and outputs are okay. And whatever the next states are
UL minus 1,
UL. Okay. And so here 0 0 0 1. Next 1 0 1 1 0 0 0 1 1 0 1 1. Intena? Is it okay?
yes, sir.
Now tell me output bits. UL plus UL minus 2. 0 XR 0 0 0 1 1 0 1 and 1 0 and 1 1, I think. 6 0 0 1 0 0 1, right? Same.
Yes, sir.
601, sir.
Where?
6 for 6.
0 1. Why 0 1? No, UL plus UL minus 2. UL plus UL minus 2. 1 plus 0 nothing but 1. 1 plus 1 0. Correct?
Okay, sir.
Okay. That is 1 1 is input is 0. Whenever input is 0, output is 1 0. Okay. Right. Now based on this, now look at the state diagram. I want to draw the state diagram here. Here I want to draw the state diagram. So 4 states here: 0 0 0 1 1 0 1 1. Now, so 0 0 is the present state. If input is 0, next state is 0 0. That is 0 by 0 0. Now 0 0 is the present state. Input is 1. Next state is 0 1. Like this. Okay. Now input is 1. What is the output here? What is the output? 1 1, right? Is it okay or not?
Yes, sir.
Okay, right. Next, present state is 0, 1. Present state is 0, 1. Input is 0. What is the next state? Next state is 1, 0. Next state is 1, 0. Then outputs are 0, 1. 0 by 0, 1. Next. Next present state is 0, 1 and output is input is 1, output is 1, 1. So 1 by what is the output here? 1, 0. 1 by 1, 0. Okay. Next. Next present state is 1, 0. Present state is 1, 0. Input is 0. Next state is 0, 0. Sorry, next state is 0, 0. Output is 1, 1. So 0 by 1, 1. Look at once. If anything is wrong, then definitely you will get the wrong answer. Next, present state is 1, 0. Input is 1. So next state is 0, 1. 0, 1. So what is the input here? Input is 1 and outputs are 0, 0. Now 1, 1 is the present state. 1, 1 is the present state. If input is 0, next state is 1, 0. 1, 0. So here 0 by 1, 0. And finally 1 by 0, 1. Look at once, all of you. Let me inform if anything is wrong. Because if anything is wrong, definitely you will get the wrong answer. That's why I'm asking you.
Same, sir.
Same.
Yes, sir.
Okay. Now tell me what is the next step? Next you have to draw the what is the next point? Next you have to draw modified state diagram. Now tell me the steps. The last class I told that in order to draw the modified state diagram, what is the first rule? What is the first rule? Please respond. What is the first rule to draw the modified state diagram?
For all zeros should be split into two states.
Right. So look at those 4 points. The first point is all zero state is split into two states, initial state and final state. All zero state is split into two states, initial state and final state. Suppose here I want to assume that S 0, 0 is the S naught state and 0, 1 is the S1, 1, 0 is the S2 and 1, 1 is the S3. Okay, just I want to assume like that. So here I want to assume S naught. Suppose S naught is 0, 0 and S1 is 0, 1 and S2 is 1, 0 and S3 is 1, 1. So all zero state is split into two states, initial state and final state. So here all zero state is the sorry. All zero state is the S naught state. So This is initial state. And final state. Yeah. Right, just wait. But S naught is the zero initial state, and finally S naught also final state. Suppose you want here, I want to take the final state. Next, coming to S1. See here, look at the state diagram. Suppose this is the output, this is the output, and this is the output. Tell me what is the weight of this output sequence? Yes, please respond. What is the weight of this output sequence? Yes, what is the answer? Weight of the output sequence.
2, 2, sir.
Weight of the output sequence is 2. That means you can write here x square. Is it okay? And weight of this output sequence is 2. Again, this is x square. And 0, 1 nothing but x power 1. And 1, 0 nothing but x power 1. Again 0, 1 nothing but x power 1. 1, 0 is x power 1. And 0, 0 nothing but weight is 0. That is x power 0. That is equal to 1. Is it okay? Weight equal to 0. That is nothing but 1. So x power 0 is equal to 1. Now S naught. So S naught and S naught to S1. Look at the state diagram. That is very, very important. Yes, this is S naught and S1 equal to 0, 1. So S naught to S1. Look at this. S naught to S1. S naught to S1. There is a path. What is the path gain for this? The path gain for this is x power 2. Is it clear? Here don't write again 1 zeros 1 ones like that. X square. Next see. And one more thing is already I told that you have to first step is you have to split the algebra state into initial state and final state. So this is the initial state, and here I am writing final state. Now 0, 0 to 0, 1, that is S0 to S1 with path gain is x square. Next S1 to, see S1 to, suppose this is S2. S1 to 0, 1 is S1 and 1, 0 is S2. S1 to S2, what is the path gain here? X power 1. So here I want to draw like this. S1 to S2, this is x1, x power 1, that is nothing but x. Next, this is S1 actually. S1 to one path is up to S2 and another path is up to S3. S1 to S3. So S1 to S3, what is the path gain here? X is the path gain. Suppose here I want to take S3. S1 to S3 is X. So the placing of S0, S1, S2, S3, that is your wish. That is your wish. Next, so S1 to S3, this path is completed, and S1 to S3, this path is also completed. Now coming to S2. So S2 to one path is up to S1. S2 to S1, that is nothing but x power 0, that is equal to 1. So S2 to S1, that is 1. This is x power 0, that is equal to 1. Next another path is, another one is S2 to S0. See, S2 to S0 with path gain x square. So S2 to S0 with path gain x square. Next coming to S3. So S3 to S2 with path gain is x. Arrow marks are very, very important because here we want to take the forward paths and loops. That's why arrow mark is very, very important. This is x. So another one is S3 to S3 only S3 to S3 with path gain is X. So finally, this is the modified state diagram for 2, 1, 2 convolutional encoder. So look at once. Please ask if you have any doubts. Yes. Any doubts? Now do you got clarity or not? Simple. Just you have to split the algebra state into initial state and final state, and you have to identify the outputs. That's why I told that if anything is wrong in the outputs, definitely you will get the wrong modified state diagram. X square X. So just weight you have to observe. So weight is 2, X power 2. Weight is 1, X power 1. Weight is 3, X power 3. Weight is 0, X power 0. X power 0 is equal to 1. Please respond. Any doubts here up to this modified state diagram?
No, sir.
Is it clear? Okay. Next, now I want to get the generating function or transfer function T of X. So here I don't want to write the augmented state diagram. This is only for modified state diagram. So next I want to draw the augmented modified state diagram. At that time you have to include Y and Z. At that time you have to include Y and Z, means you have to increase by adding something, that is by adding Y and as well as Z. So here I want to identify forward path, and I want to identify loops, and I want to identify non-touching paths. What is the reason for identifying all these things? Because when you go for the formula, T of X is equal to sigma I Fi delta I by delta. So Fi nothing but, what is Fi? Gain for the ith forward path. That means you have to identify the forward path, you have to identify the loops, and you have to identify the pairs of non-touching loops and pairs of triples of non-touching loops and up to so on. Already I told that sigma in brackets set of I, set I comma j, set I comma j comma k, and Fi, Ci, all those things, right? So first I want to identify the loops. Look at the modified state diagram. Tell me that how many number of loops here? How many number of loops? So one loop is C here. This is one loop, right? Starting point S3 and ending point also S3. Starting point is S3, ending point also S3. So this is the first loop. Starting point is S3, ending point also S3 with gain. What is the gain here? C is equal to X. Suppose this is C1 is equal to X. Only one state here, S3. So right, you C1 is equal to X. Actually, I told that Ci denotes the gain of the ith loop. Suppose here I want to go for the first loop, so C1 is equal to X. Next, is there another loops? Tell me another loop. If any loop is exist, please tell me the answer.
Between S1 and S2, sir.
Right, that is S1 to S2, again S2 to S1. This is another loop. That is starting point is S1 and S2, again it come back to S1. So with the gain, so this is the second loop. So C2 equal to, what is the gain here? X and 1. So X into 1. You can write again X. Is there any other loops? Look at the diagram. Is there any other loops? So one more loop starting from the S1, S3, S2, S1. So this is the path. Don't think that this is the path. So here the path is this one. So this is the path. That means here third one is starting point is S1, S3, S2, S1. So with the gain C3. Now tell me what is the gain?
X square.
Is it X square or X cube?
X cube.
X cube or X square?
X
X square,
X
sir.
square, sir.
Square only. Okay. So look at the arrows here. So S2 to S1, having the gain is only 1, path gain is only 1, not the X. This X is from S1 to S2, but your loop is from S2 to S1. So C3 equal X square. Is there another loop? No, only 3 loops. C1 equal to X, C2 equal to X, and C3 equal to X square. Next I want to write the set of Y comma J. that means pairs of non-touching loops. Pairs of non-touching loops. That is, now tell me, pairs of non-touching loops. Which two loops are non-touching? Actually, is there any non-touching loops or not? First, you have to identify that. First, you have to identify is there any non-touching loops or not. Look at the state diagram.
Loops
Modified state
1
diagram.
and 2.
1 and 2 non-touching.
Yes, sir.
See, so this is the first loop, and this is the second loop. So in the second loop, states are only S1, S2. In the first loop, states are S3. So there is no common state. There is no common state. That's why you can say that there is one pair of non-touching loop. That is 1, 2. 1, 2 with C1, C2 equal to X square. Okay. With C1, C2 equal to X square. Now coming to triples of non-touching loops. So when I draw the state diagram, there is no triples of non-touching loops. No triples of non-touching loops. Okay, with this loops point is completed. Loops is completed. So whenever loops are completed, now we can write the formula as delta equal. What is the formula for delta? Do you remember the formula for delta? Delta is a parameter. We can define delta equal to 1 minus S. What is the formula? Delta formula.
1 minus sigma I Ci plus sigma ij
1
Ci
minus
Cj.
sigma I Ci plus sigma I comma j Ci Cj and minus up to so on. But here I don't want to write the triples here because no triples of non-touching loops. Only pair of non-touching loops are available. That is, you can write 1 minus how many loops here? 3 loops, right? 3 loops. That is C1 plus C2 plus C3 plus how many pairs of non-touching loops? Only one pair of non-touching loop, that is C1, C2. Is it clear? 1 minus of C1 plus C2 plus C3 plus C1, C2. Again minus here. Actually, no non-touching loop, no triples of non-touching loop. That's why remaining all are zeros. One minus 2x. Zero, okay? Delta equal to 1 minus 2x. Now I want to go for the forward work because actual formula is P of x is equal to sigma Fi delta I. Fi delta I is the formula. Fi delta I by delta. With this delta is completed. Now I want to find the delta I and as well as the Fi. So Fi nothing but forward path. That's why I want to write the forward path. Forward path. Now identify how many number of forward paths are available. So actually first you have to identify is there any forward path or not. Look at the modified state diagram. Is there any forward path? Forward path. from the initial state. You have to start from the initial state and you have to end with a final state. starting from the initial state, end with the final state. So S0, S0, S1, S2, S3. This is one forward path, right? Another forward path is S0, S1, S3, S2, S0. This is another forward path. Is it clear? Once again, I'm repeating. S0, S1, S2, S3. One forward path. S0, S1, S3, S2, S0. This is another forward path. So total 2 paths are available. So I want to draw the, or I want to write the forward paths here. So first forward path is S0, S1, S2, S0 with gain. Now tell me what is the gain here? With the gain Fi, ith forward path. So first forward path. So F1 equal to. What is the gain? Look at the modified state diagram. Tell me the gain.
X power 5.
Right? X square, X square. That is X power 5. Now coming to second forward path. S0, S1, S3, S2, S0. So second forward path you can write F2. What is the gain? No problem. You can take, this is the first one, this is the second one. Don't confuse. You can take F2, this is the first one, this is the second one, or you can take first one, second one. No, there is no rule. First you have to take only this path, next you have to take only this path. There is no rule like that. So F2 equal to, now tell me, what is the gain?
X power 6.
X power 6. Okay. So F1, F2 completed. What is the next step? What is the next step? You have to draw the graph GI. That's why I told that those points are very, very important. Now you have to go for the graph GI. That graph GI can be obtained by removing the states on the forward path. Here GI is the graph. So this can be obtained by removing the states of the forward path I or Fi. By removing the states of the forward path. Suppose if you want to draw the G1, you have to remove the states of the F1. If you want to draw G2, you have to remove the states of F2. If you want to draw D3, G3, F3, G4, F4 and up to so on. But here only 2 forward paths. That means you have to draw only 2 graphs here. So one is G1, this is one is G1, another one is G2. Suppose if you have 3 forward paths, you have to go for graph G1, G2, G3. Here only 2 forward paths. The first, that's why first I want to draw the G1. So in order to draw the G1, you have to remove the states on the forward path 1. In order to draw the G1, states of the forward path 1. Now tell me, what are the states are present in the forward path? S0, S1, S2. The states in the present state is S0, S1, S2, S0. That means how many states? 3 states here. 1, 2, 3. Now you have to remove these 3 states. By removing these 3 states, what is the remaining state? Only S3. Remaining state is only S3. Now like this. This is X. So this is the graph G1. Is it clear now? This is the graph G1. And now tell me, what is the parameter delta 1 equal to? What is the delta 1? Again same actually. Again you have to find C1, C2, C3 and pairs of non-touching loops, triples of non-touching loops and 4 times of non-touching loops. Again you have to find like that. Again you have to find like that only. But by looking at the figure directly you can say that only one loop is there. That loop is X here. So you can write delta 1 equal to 1 minus X. Is it clear all of you? Actually here point is for this graph G1 again you have to find loops here. Again you have to find the loops. So how many number of loops are present? Next, how many pairs of non-touching loops and triples of non-touching loops, 4 times of non-touching loops. Again you have to find all those things. Here only one loop is present, that is C1 with gain is equal to X. Is it okay? C1 with gain is equal to X. So you can write delta formula is delta 1 equal to 1 minus sigma C1. So only C1 is present here, C2, C3, C4 not present here. So you can write 1 minus X. Is it clear? All of you, please respond.
Yes, sir.
Now coming to G2, because there another forward path is there. Now you have to draw the G2. So in order to draw the G2, you have to remove the states in the second forward path. What are the states in the second forward path? S0, S1, S3, S2. That means you have to remove S0, S1, S3, S2. All these paths you have to remember. When you remove all these paths, now what is the graph here? What is the graph here? So graph is empty. There is no graph actually. There is no graph. Now tell me what is the value of delta 2?
1, sir.
Right. Actually 1 minus sigma C1 plus C2 plus C3 plus up to so on. No loops here. No loops. That means delta 2 equal to 1. So delta 1 equal to 1 minus x and delta 2 equal to 1. Now I want to write the, I want to find the transfer function. So transfer function T of x is equal to, actually what is the formula? What is the formula? Sigma Fi delta I by delta, right? Is it okay? Sigma Fi delta I by delta, and that equal to now F1 delta 1 plus F2 delta 2 by delta. F1 delta 1 plus F2 delta 2 by delta, and that equal to, what is F1 again? F1 equal to x4 5, and this is 1 minus x, plus F2 is x4 6 into 1 divided by, what is delta? 1 minus 2x. 1 minus 2x, and that equal to x4 5 minus x4 6 plus x4 6 by 1 minus 2x, and that equal to x4 5 by 1 minus 2x. Now that equal to, you can write x4 5 into 1 minus 2x whole power minus 1. Again from the binomial expression you can write x4 5 plus 2 into x power 6. Directly I want to multiply, plus 4 into x power 7 plus up to so on, plus 2k x power k plus 5 plus up to so on infinity, or 2 power n x power n plus 5 up to so on infinity. Is it okay? So what is the formula? 1 minus 2x power minus 1 nothing but 1 plus 2x plus 4x square plus 6x cube plus up to so on, right? That is the formula. And after writing formula, directly I want to multiply with x power 5. Now final answer is x power 5 plus 2 power x power 6 sorry 2x power 6 plus 4x power 7 plus up to so on 2k x power k plus 5 plus up to so on. This is the transfer function or generating function for the 2 comma 1 comma 2 convolutional encoder. Given 2 comma 1 comma 2 convolutional encoder. Like that you have to complete the problem. So here finally one point I want to say, that is with this with this equation you can say that, see here 1 into x power 5, important point, 2 into x power 6 sorry 4 into x power 7 plus up to so on. That means you can say that one code word of weight file. So this transfer function is having one code word of weight 5, 2 into x power 6, meaning of that is 2 code words of weight 6, 4 into x power 7, so meaning of that is 4 code words of weight 7. Is it okay? Finally, suppose the question is how many number of code words of weight 5, how many number of code words are weight 6, weight 7 up to so on. Now answer is like this, you have to remember x power 5, 1 into x power 5, meaning of that is 1 code word of weight 5, 2 code words of weight 6 and 4 code words of weight 7 and up to so on. Now tell me what is the free distance? Yes, what is the free distance? Anyone? Please respond. What is the free distance?
Minimum Hamming distance.
What is the answer? So free distance is what is the minimum distance among these? See, code word of 5 nothing, but what is the meaning of this? Number of non-zero elements is 5, or you can say that directly d free equal to 5. Is it okay? So that's it about the transfer function.